All right, so now we're going to move on to lesson 6.3, which is going to be adding and subtracting rational expressions. So up until this point, we've done division, we've done multiplication, we've stated the non-permissible values, which is pretty standard for rational expressions. But now we're just going to add the adding and subtracting operations and see how these look. Now, first and foremost, we want to make sure that our fully factored denominator is present, because if the denominator is not fully factored at that point, then we won't be able to easily tell what is that common denominator we're looking for, or what we're going to call our LCD, or often called the LCM, but LCD. So we want to fully factor our denominator. Once the denominator is fully factored, let's make sure to state our non-permissible values, because clearly we have to make sure that we account for what the x or t or whatever that variable cannot equal, because we can't have a denominator that goes to 0 or else it becomes undefined. We then want to determine the lowest common denominator, or the LCD. Sometimes I'll even call that the LCM, but for this lesson we'll call it the LCD, or lowest common denominator. We're going to express each as an equivalent fraction such that we have one LCD, or one denominator, and then a few terms that might come together in the numerator. We'll combine those numbers in the numerator by adding or subtracting like terms. And then lastly, we'll just make sure we factor it, or keep it in its factored form, but reduce the number if possible. Now, let's take a look at some examples where we're going to have to add or take the difference of numbers, aka take the sum or difference, depending if it's added or subtracted, and we're going to see what these things become. Now, in the first one, right away, we look at this and we're like, is it fully factored in the denominator or in the numerator? Yes, it is, because realistically, we look at this and we're like, there's nothing you can pull off of 2n or 5n that would separate them or pull out a GCF. I mean, we could put out an out front, but that might be a little overkill. Now what we want to do is we want to state the NPV. So as soon as we factor it, we're like, okay, so clearly the NPV, and let's make sure I do this in black here. So the NPV is where n cannot equal to 0. If n is equal to 0, it's going to wipe out the denominator, and clearly we don't want to have that, so we're going to just say, hey, you know what, we're going to say that n cannot equal 0. Now from here, we need these denominators to be the same, so we're thinking, what can we multiply top and bottom such that both these become the same? Well, if I look at these two numbers, 2n and 5n, these both, the first number that 2 and 5 multiply to commonly is 10. So we're going to multiply them both by 10, numerator and denominator, and the n is already there, so we don't need to worry about that, and we're just going to see if we can match these both to be 10. Now, what I'm going to do is, often in these problems, I'm just going to rewrite out the given situation. I mean, you don't necessarily have to, but I want to rewrite it out just so that we can clearly show the multiplication step that's happening in the numerator and denominator. Now, I'm going to surround the first one, I'm going to surround the second one, and then again, we're going to have to multiply these to get to 10. So what I'm going to do is say, well, 2 times 5 gets me to 10, and I'm going to write it as 5 divided by 5. I'm going to multiply the second fraction by, well, 5. To get it to 10, I have to multiply it by 2. So I'm going to multiply 2 numerator and denominator. Now from here, this is going to give us where we have 5m in the numerator divided by, and at this stage, since I know that there's going to be a common LCD, or lowest common denominator, what I'm going to do is I'm going to look at this and be like, hey, let's just make one denominator. That one denominator is equal to the 10n, because 5 times 2 is 10, 5 times 2 is 10, and then we just had the n there. And then in the numerator, what I'm going to do is I'm going to multiply this out. It's going to be 2 times m plus 1. There we go. Now, what I'm going to do very, very quickly here is I'm actually just going to shuffle all of this down. And the reason I'm going to shuffle all of this down is because it might make sense organizationally just to state the LCD right away. So I'm going to be like, hey, the LCD, before we even have begun, is equal to 10n. This might be a good thing just to throw right before you actually start doing the algebra so that we can see the simplistic form. Now from here, I'm going to go down and be like, well, if I expand this, it's 5m minus 2m, and I'm going to expand this. This is going to be 2m minus 2, because the negative goes to both, and then this is going to be divided by the 10n. And then from here, what I'm going to do is combine my like terms. From here, I see that we have 5m minus 2m, that's 3m, minus 2 all over 10n. Now, at this stage, what you would want to do is, obviously, I think it might make sense to even put some equals here. So I'm just going to go down the line and put equals, because these are technically all equivalent form. They're just reworked forms of each other. So I'm going to put equals on the outside here. And then I'm going to look at this and be like, can I reduce 3, 2, and 10 all by the same thing? Or even reduce the m's and the n's? The answer is no, and therefore this becomes the answer here. So this would be our completed solution. We'd be happy with this. And again, if you could factor something out, maybe you factor it at this point, but there's just really nothing we can factor out, and there's no sort of simplification, so we're happy with this. Okay, let's go over to B. So we're going to do a very similar structure here. We're going to look at it and see if it's factorable. And in this case, it's not factorable. So I'm going to go, okay, well, what is the non-permissible value? Our NPV, or non-permissible value, is where t cannot equal 0. Because if t was 0, it would wipe out both denominators, and we don't want that. Now that we've accounted for the NPV, we're going to state our LCD, just like we did before. So LCD, well, what is the first number that 7 and 21 multiply to? It's actually 21 itself, so I'm going to write 21. What is the lowest, or what is the highest amount of t's, I should say, that would make them match? In this case, it's t3. So we want both the denominators to be 21t cubed. The only way we can do that is to multiply the first fraction by some sort of term. So let's rewrite this out as 3 over 7t squared. And then this is going to be minus 2 divided by 21t cubed. Now what we're going to do is we're going to surround both of the fractions. And from here, I'd be like, okay, well, if I know the first, or if I know the second fraction is 21t cubed, then I don't really have to do anything with that one. What I need to do is I need to multiply this fraction by 3t over 3t because I need it to become 21t cubed. So I need to multiply it by 1t to make this go by power rule to t cubed. I need to multiply the 3 times 7 to get it to 21. There we go. Now, again, did we really even need to surround the second one in brackets? So this one here, not really, but I mean, like, just to show that, hey, we might have to multiply by something. Why not? So this is going to be equals to, now it's going to be equals to below. I'm going to write this as 3 times 3, which is 9. The t goes with it, divided by, remember, as soon as we know that this is a lowest common denominator in LCD, I'm just going to write it as one fraction. So this is 21t cubed. In the second fraction, we didn't multiply anything to 2, so this will just become minus 2. And I guess I can kind of take away all this and maybe even shuffle the 21t cubed over a little bit. Now from here, we go, can we reduce anything more here? Well, we have 9, 2, and 21. They all don't reduce by some term. We have the t cubed and t and no t's, so we can't really take this any further. This has to be the answer right here. As soon as we get it to this form, we're like, nothing more we can do here. This is it. And again, very, very similar structure overall. We look at this and we're like, hey, you know what? We've stated our MPVs, so we know what one we have to account for. We know our LCD, or the common denominator. So from here, as long as we can get it to here, we're happy here. Okay, now let's go down to part C. Now, we see a binomial and you're like, this is a little bit different. What I want you thinking about is, first and foremost, let's state our MPV. So I'm going to do that right here. I'm going to be like, MPV is where 4m minus 3 cannot equal 0. We want to isolate it so that we get a specific m value. If we isolate it using algebra, we figure out that m cannot equal positive 3 divided by 4. And if you don't believe me, just take a couple seconds to do that algebra to isolate for m. So m cannot equal 3 over 4. As long as it's not 3 over 4, we're going to be happy with this, any sort of value here. Now, the other piece is, we look at this and we're like, it's a binomial squared, a binomial cubed. The only difference between these binomial denominators is that this one has 2 of them, this one has 3 of them. So as you can imagine, what we're going to have to do is we're going to have to state that our LCD in this case is the one that includes 3 of them. So let's do that here. LCD is going to be 4m minus 3. I'm going to keep it exactly how I see it in that format, and I'm going to write it to the power of 3. So I'm going to have to multiply that first fraction by 4m minus 3 in the top and bottom in order to match this as a cube. Let's show what that looks like below. So this is going to be equals to, I'm going to write it as 2 divided by the 4m minus 3, and this was all squared. Just to get my operation right, it was minus 8 minus 2m all over the 4m minus 3. And this was cubed. And then I'm just going to make sure everything's right. Yep, perfect, looks good. Now from here, I need to multiply this first fraction by 4m minus 3 in order to get it to match. And you're probably looking at this and being like, wait, Mr. T, they already do match. No, we got to make sure that this is a squared, because that was the squared in the problem. And then the other thing is I'm going to do is just kind of clean up this bracket just a little bit. I think it could be a touch better. There we go. So let's surround that. Now I'm going to write this as, on the outside, this is going to be 4m minus 3 divided by 4m minus 3, because we need to multiply it numerator and denominator. Now from here, this is going to be equals to, I'm going to expand this. So equals, we go 4m times 2 is 8m. Negative 3 times 2 is negative 6. And this is going to be all over. We're going to put our single denominator, 4m minus 3, and then all to the power of 3, like so. Perfect. And then for my second one, there's a negative that goes to both of these terms. So this negative applies to both of these. So it's going to become negative 8 and then plus 2m. Now what we're going to do from here is just simplify this into one sort of numerator with like terms. 8m plus 2m is equal to 10m. Our negative 6 and negative 8 give us negative 14. And then this is all divided by the 4m minus 3 all cubed. Awesome. Now, there's only one thing we could do potentially here, and that would be remove a common factor in the numerator, because I want to keep it in the factored form for the denominator. I don't want to expand that. In fact, the expansion would be crazy. So I'm just going to leave it as that. I'm going to take out a factor of 2, which transforms this to be 5m minus 7, and then all divided by, in the denominator, 4m minus 3, and raised to the power of 3. Awesome. There's your answer. Okay. Now, I'm just realizing, did we state our MPV? Yes, we did. Just to make sure, you always want to go back and double check just to be like, hey, you know what? We got to make sure that we account for what the values can't be, because otherwise we're including restricted values, and we definitely don't want to do that. So there's our final answer. And again, make sure you leave it in the factored form when you get to the answer. Okay, let's go over to this one. You're probably looking at this one being like, whoa, there's a lot going on here. What is happening? Now, first and foremost, let's state our MPVs. We're going to look at the denominator and say, what values of x can this not be? Well, x cannot equal, in the first bracket, it can't equal 3 or else that one would become 0. It can't equal 1 or else that one becomes 0. And then other than that, we look down the line and we're like, there's no other factors, or there's no other like x's we need to account for. So we look at this and we're happy with x being not equal to 3 or not being equal to 1. Now, in order for these denominators to match, the only thing that's different about them is they all have the x minus 3, x minus 3, x minus 3, and the x minus 1, x minus 1, x minus 1. So they look the same in terms of their binomials. It's the numerical coefficient that's different about them. So to make these all match, what we're going to do is force them such that they all have the 4 with them. Now, to make that work, we're going to have to multiply this fraction by 2, this fraction by 4, and then that will give us the ability to do that. So maybe what we'll do is, just to save a bit of space, because I mean, rewriting this might be a little bit and it might be a little too long. Actually, you know what? We're not going to be lazy with it. We're going to write it out. So I'm going to take this and be like 2x squared minus x divided by, we have our x minus 3. And I guess it doesn't really matter if I put the 1 or the 3 first. It could be either way. Minus 3 plus 6x divided by 2 x minus 3, x minus 1. There we go. And then plus, in the numerator over here, 8. And this is all over 4, x minus 3, x minus 1. Awesome. So now once we have it here, I'm just going to write that this is equal to, and now the ones that we need to expand to be a little larger in terms of we need to make sure they have that same numerical coefficient, I'm going to multiply this one by 4 over 4, because this one had no numerical coefficient, or 1 more specifically. So to make it to 4, we have to multiply it by 4. I'm going to then surround the second grouping, and we have to multiply this one. Let's see if I have a bit of space to space this out, because I think I need to just give it a little bit of space out in front so that we can put a numeric coefficient here. In order to make this go from 2 as the coefficient in the denominator, I need to multiply this by 2 over 2, which will force that to be 4. Now, if I rewrite this out, here's what it's going to become. This is equal to 4 times 2x squared is 8x squared. 4 times negative x is negative 4x. And then what we can do again is we can just do a big denominator and write the same denominator. It's going to be 4x minus 3 and x minus 1. Because remember, as soon as you know what the denominator is in terms of that LCD, we can then write it all together here. And now from here, what I can do is write this as continuing this down. If I write this, what happens with this expansion, negative 2 times 3 is negative 6. Negative 2 times positive 6 is equal to negative 12x. And then from here, we have that positive 8 on the end. What we're going to do is we're going to collect our like terms to finish this off and get a specific answer. So in terms of x squareds, I mean, I only have the 8x squareds. In terms of the x's, negative 4x and negative 12, I have negative 16x. In terms of constants, I have negative 6 and 8, which is positive 2. And then this is all divisible by the LCD, which is 4x minus 3, x minus 1. Okay, now there's one thing I'm realizing we can do with this, and it's just to reduce this in terms of a common factor. If you realize that all of the terms are divisible by something, in this case we have 2, 4, 16, and 8, they're all reducible by a factor of 2. Let's just divide them all by 2. So this is going to become 4x squared. This is going to be negative 8x. This is going to be positive 1. And then lastly, in the denominator, if we divided the 4 by 2, it was 2. And then our binomials stay the exact same, x minus 3, x minus 1. There is our answer. Now, as I filled this out here, I'm just realizing that we've kind of went against the pattern that we've just talked about. So the pattern was we wanted to state an LCD. What I'm going to do is I'm just going to move my MPVs over just a tad like this. And then I'm going to put the LCD right next to it just so that we know we have it here and just so that it follows the pattern we've been writing before. So our lowest common denominator, it was 4, x minus 3, and x minus 1. It's just so that we can see it, because if we can write it out, then we know what we're targeting and we know what we're moving towards, so it might help us there. Okay, perfect. Let's just double check the formatting on this page, make sure it's all okay for us. Yeah, perfect. We've stated LCDs, MPVs, and we've stated a final answer in its most reduced form. So I'm happy with this. All right, now with these sorts, one last note about this one. If the trinomial is something that can factor nicely, I mean, go for it. So let's say it was something that could split into like a x plus 4, x minus 1, or an x plus 3, x minus 2, something like that, where it's two binomials, they're nice, you can factor them by decomp or by inspection, go for it. But in the case of this one, the numbers that would factor, if they could factor, aren't going to be nice. So, I mean, I'm just going to leave it as this. And as long as our common terms are brought together and our denominator is in its factored form, I'm like, this is more than I can be happy with. So I'm looking at this being like, this is good. Okay, let's move on to our next page here. We're going to look at a couple more examples here, and we may take some shortcuts here or there just based on the space we have available. So instead of rewriting them out, what I might do is just like write on the actual examples themselves, just so that we can save a little bit of space here. So they say simplify and identify all the non-permissible values. Well, first and foremost, our MPV for this one is quite nice. MPV for the first one is just that y cannot equal 0, because if any y was 0, it would wipe out those denominator terms, and we don't want that. Now, we want to state our LCD. Our LCD in this case scenario, or lowest common denominator, 3, 2, and 6 all multiply to make 6. And then in terms of the y's, it's y cubed that is the common y's that we need to aim towards. So we take our highest amount in the variable, and then we take whatever the first number our other coefficients can multiply to, in this case 6. Now what I'm going to do is I'm going to multiply them all accordingly. So what we have to do is, for the first one, we're going to take this and be like, let's surround it in brackets, let's surround the second one in brackets, and here's where I need you to be very, very notationally accurate with these things. And this is what causes a little bit of difficulty. So actually, you know what, maybe we're going to try to rewrite it. I know the space is limited, but let's just try to rewrite these here, because I do want to be very accurate, and I know that this pops up typically on the first quiz as well. So I write this as 2x3y plus 3x over y squared, and not just y squared, but 2y squared, and then minus 5x all over 6y cubed. Awesome. Okay, now with these ones, when we know we have to multiply them, what I'm going to do is I'm just going to give each of these coefficients a little bit of space, and you're going to see why just in a second. What I recommend is you want to try to, whoops, and I don't want to take the y with it. When we're dealing with these types of problems, we want to try to give a little bit of space as the coefficient, because we want to be able to put in a fraction of multiplying and dividing. So in this situation, I'm going to multiply this first one. If I want to get to 6, I must multiply by 2, but I also want to get it to y cubed, so I'm going to multiply it by 2y squared divided by 2y squared. I'm going to do both of those together, and let's just clean that up, make it a little bit neater here. So this is over 2y squared. And again, what we do to one side, or what we do to the numerator, we must do to the denominator. That's extremely important. Now what I'm going to do is surround the second term in brackets. If I want to make this go from 2 to 6, I must multiply it by 3. And then it's already at y squared, so I'm just going to multiply it by y. So this is 3y divided by 3y. I can't emphasize how critical that is, doing exactly how I just put this in here and wrote this in. You must multiply it to the numerator and denominator. I know it's really tempting just to write it out one time and just say, hey, I know it goes to the numerator and denominator. If I just write, let me just demonstrate it here. Hey, if I write 2y squared, oh, that's going to multiply to everything here. Not to a formalized mathematician. You would look at that and be like, oh, they're just multiplying it to the numerator. So very important you show it happening in the numerator and denominator as this, because again, what does any of these reduce to? 3y over 3y, 2y squared over 2y squared? They actually are just 1. And if you show it like this, it's obvious, but otherwise it might not be so obvious. Now from here, let's make sure we write it as one numerator. So I'm going to write this as equals to, we're going to expand this out. So it's going to be 2 times 2, which is 4. The y squared and the x are going to come together in the numerator as such. There we go. This is going to be plus 3 times 3 is 9. The variables come together to make xy, and then minus 5x. And then this is going to be all divided by the common denominator, or the LCD, 6y cubed, because all of them would multiply to make 6y cubed. Now, in this situation, I see something that I can remove from all the terms. In fact, I can actually rewrite this where x is on the outside. So maybe I'll just do that here, and I'm going to try to not interfere with the next problem here. This is going to be x times, our first coefficient was 4, so it's going to be 4y squared. The next one is going to be 9y, because I've removed the x, minus 5, which is the constant, and then all divided by, in this situation, 6y cubed. Awesome. So if you can remove out a common factor, I highly recommend doing that. I know space might be limited, but that's exactly how we want to do these problems. Okay, let's move on to part B. Very, very similar. We're going to state our MPV right away off to the side. MPV is where x cannot equal 0. If x is 0, it's going to wipe out all the denominators. Now, our LCD, we're going to write this as, well, let's just see. If we take 56, for example, and we want to see if that's actually the lowest common denominator, what I'm going to do is I'm going to be like, well, 56, does it divide by 7? It does. And then if you look at 56 and you divide it by 3, you're like, oh, it doesn't quite work. So now what you have to do is be like, what is the first number that 3, 7, and 56 all multiply to? And then hopefully we can generate a common understanding here. If we wanted to do this, we're like, okay, well, we know that if I take 56 times 2, that's going to give me 112. Is 112 divisible by 7? It is. Is 112 divided by 3, is that a thing? No, not in that case. So we maybe got to take it one step higher. We're looking at this and being like, well, if I take 56 and I times it by 3, so 56 times 3, this is going to be equal to 168. 168, if I divide that by 3, it is divisible. If I take 168 and divide it by 7, it is also divisible by this term here. And so all of this in short form, just to say that our common denominator, or LCD, is 168x, because 168 is the first number that all of these evenly are divisible by. Now, what we're going to do is we're going to write this below. So I'm going to rewrite the fractions as 2 over 3x. And then again, I'm going to try to leave a little bit of space in front of each of them. So 5 over 7x for the next one. And then minus, we're going to leave a little bit of space, 3 over 56x. Now, what we're going to do is we're going to expand these all to be a 168x denominator. To do that, I have to take 168 and I'm going to divide it by 3. This tells me how much I need to multiply it by. This first term is going to be multiplied by 56 over 56. The second term, this one, we're going to multiply it by, if I want to take 7 and multiply it to 168, I have to multiply it by 24. So this one's going to be 24 divided by 24. And then lastly, if I want to take 56x and multiply it to 168, I go 3 divided by 3. Because if I take this and I'm going 56 times 3, that will give me the 168 I'm looking for. Now from here, again, with any of these fractions, we know that they all just cancel to 1. So it's not that we're actually changing the terms, we're just scaling them all up appropriately. This one is going to be equal to, the first one, 56 times 2, this is going to be equal to 112 divided by in the denominator. And actually, let's just do all the numerators first, because we know our numerator is going to stay the same. 24 times 5 is going to be equal to 120, so we're going to go plus 120. Minus, in the numerator, this is going to be 9. And with these ones, because there's no variables in the numerator, then we just have all these numeric values. Divided by, in the denominator, this is 168x, because that was our LCD. Now what we're going to do is just combine our terms together. So this is equal to 112. So 112 plus 120 is equal to 232, minus 9 is equal to 223. We end up getting 223 divided by 168x. And then you just want to be thinking, can you reduce that anymore? And in most cases, like, especially when it's like an even over an odd like this, I would assume no. But just in case, I would always type it into your calculator as 223 divided by the 168. You can do your math frac key, and then you would find that, yeah, there is no other reduction here. This is as far as it can go, because they wouldn't share any other common factor like a 5, a 7, like any of those prime factors would be off the table here. So this is what we would get for our solution. Now, just as a way to prevent this from interfering into our next problem, what I'm going to do is I'm just going to shift all of this work that we've done just over a little bit, just so it lines up nicely, and that we can continue the problem there. Perfect. All right, now let's go down to our next problem here. Part C, we see one of them doesn't even have a fraction entirely, so that's kind of interesting that we see that, but maybe that helps us a little bit. What we're going to do is we're going to state our non-permissible value, so our MPV right away is where m cannot equal 0 because it's an isolated variable. We can basically just say that as long as it's not 0, we're happy. Our LCD, we want to think about this and be like, what is the first number that 6 and 8 multiply to? In this case, 6 and 8 both multiply to make 24. So let's make our LCD 24. And then we're going to not only make it 24, but it must include an m there as well. So as long as we can multiply each term to make this 24m, we're happy. I'm going to start by writing this out as equal to 5 over 6. And let me make sure I leave space here. 5 over 6m. And then minus, we have 3 over 8m. And then plus the 2m. There we go. And let's just make sure that the operation's clear. Now what I'm going to do is go one by one and see what we have to multiply them by. In the first fraction, to get 6 to make 24, I have to multiply it by 4. So I'm going to go 4 divided by 4, which will give me that first term. My second term, I'm going to multiply this by, well, to get 8 to 24, I must multiply by 3 over 3. And then lastly, for this one, I must multiply it by, if I want to make the 24m in the denominator, I have to actually multiply this by 24m. And so let's just make sure that's a tad bit clearer. I know it might be a little condensed, but we're going to try to squeeze it in there. 24m and then 24m. Perfect. Now when we expand this out, here's what it's going to become. And I mean, if you really wanted to as well, you could write this over 1 if you really wanted to, just to show that it does have a denominator that you multiply to. This is going to be equal to 4 times 5 is 20, minus 3 times 3 is 9, plus 24 times 2 is 48m squared, because there was both an m on there. Now I'm going to go divided by. From here, I'm going to look at this and be like, well, all the denominators make that 24m. So let's just make sure we put 24m down there. This is going to be equal to 20 minus 9 is 11. And just by descending order, I'm going to write the 48m squared minus 11, or plus 11, I should say, not minus. There we go. And then all divided by 24m. Now, the one thing you just want to double check at this point, can they all reduce by something? In this case, 11 is a prime number, 48 and 24 even. There's nothing I can divide by that's common, so I'm just going to highlight this and say, yep, this is good to go. All right, let's go over to part D. Part D, very, very similar to ones we've solved before. We look at this and we're like, okay, the denominator, it looks like we just can't have 0 because if C was 0, it would wipe out those terms, and we don't want a denominator that's 0 or else it makes it undefined. Now from here, we go from here and we're like, okay, 3, 2, and 1. The first number that those all multiply to is actually 6. So our LCD that we're going to look for, or LCD, LCM if you really want to, is 6. And then the highest amount of C's is C4. So each denominator has to be 6C4. Now, just as we've done before, we're going to write equals to. We're going to leave a bit of a space out in front and be like, this is 4 over C squared, and more importantly, 3C squared. And then minus, leave a bit of a space, 5 over 2C cubed, and then plus, leave a bit of a space, 6 over C4. Awesome. Okay, let's go one by one and multiply them. So to get this one to be our 6C4 that we're looking for, we're going to have to multiply it by 2C squared. Because by product rule, we need this to add their exponents. C2 and C2 make C4. I'm going to then multiply this one. If I want to make this go from a 2 to a 6, I must multiply by a 3. And then C3 to get to C4, I need 1C in there. So we're going to multiply by 3C and 3C. And then lastly, we just see that there's not a 6 out in front. So we're going to multiply it by 6, and then we're happy. Now, continuing this down below, 2 times 4 is going to be equal to 8C squared. Minus 3 times 5 is negative 15C. Lastly, 6 times 6 is 36. There we go. We're going to divide this all by the common denominator of 6C4. And now we just want to look at this and be like, are they all divisible by some term? If we look down the line, if I look at 8 and 6 and 15 and 36, unfortunately, they don't all divide by something like 3. They all don't divide by 2, and they all divide by 1, but I mean, we don't consider that prime numbers. So at this case, there's really nothing we could do. I mean, maybe you could try and factor the numerator, but even then, we don't really have a common C to pull out. There's no sort of like easy factors for this one. So I'm going to look at this and just say, you know what? This is our answer. Perfect. As long as we've collected our like terms, we're happy. Okay, let's go down to E now. This is going to be one of the first times we see binomials, which is kind of a lead-in for our next lesson. When we see these binomials, simply put, we just want to look at this and be like, our non-permissible value comes from the inside of the binomial. If x plus 3 is the binomial, then if x was equal to -3, it would cause this to be 0, and clearly we don't want that. So we're going to write this as our NPV is x cannot equal -3, just like it was in quad equations when we did the opposite of the brackets, or quadratic functions, we took the opposite of the bracket. This is no different. Now we want to state our LCD. So our LCD, or lowest common denominator, what multiplies, or what's the first number 2, 5, and 2 multiply to? It's 10. So we want to put 10 as the numeric LCD, but each of them must also have the x plus 3. So as long as we can make each have a factor of 10 and then a factor of x plus 3, we're happy with this. So we're going to write below here. I'm going to start with the first fraction, 6 over 2x plus 3. And just make sure you leave a bit of space out in front, just like we've done before. This is going to be 4x squared with 5x plus 3. And then lastly, minus x, like this, x over 2. Awesome. Okay, let's go one by one here. So for the first one, surround it in brackets. If I want to make this go to 10, I must multiply it by 5 over 5. For my next one, I must multiply this common factor. For this one, and I'm going to just clean that up just a tad bit here because the operation is a little bit farther out here. So let's put that there. And then I'm going to try and make the bracket go outside of that bracket. There we go. That's a little better. Then I'm going to multiply this one by, in order to get 5 to make 10, I'm going to write this as 2 over 2 right here. So 2 over 2. And then lastly, for this one, x over 2, we need to have it as a denominator of 10, but also x plus 3. So I must multiply each of them by 5x minus, or x plus 3, I should say. And it's going to be a little squishy here, but x plus 3, and divided by the 5x plus 3. Perfect. A little bit squishy, but it will do. Now, from here, what we're going to do is we're going to expand them all out. So in the numerator, 5 times 6 is equal to 30, plus 4 times 2 is 8x squared, and then minus, here's where it becomes a little difficult, is that we have this sort of binomial term, or two things going on here, times the x. Let's just save the minus for a second. I'm going to multiply everything together. So it's going to be 5x plus 3, or 5x plus 15, because we're going to multiply that 5 in, and we're going to multiply each of those by x's. If you expand this all out, or this piece here, ignoring that negative, what you're going to end up getting is that this is going to be 5x squared, and then plus 15x. There we go, because each of them will get an x. And again, I'm just going to keep that negative just out in front, just for now, and then I can always put that in. In the denominator, we're going to have 10x plus 3, because that was our LCD we've just discovered. I'm going to collect the like terms here. So if I do that, we're going to take 30, which is a constant term. It's going to remain unaffected. 8x squared minus 5x squared is 3x squareds. Then we're going to put our negative 15x, which is from our expansion of that negative, plus 30, because there was no other constant terms to bring. And then this is going to be divided by 10x plus 3. Now, ideally, you would look at it in this situation and say, well, what is a common factor here? In the numerator, it looks like we can remove out a factor of 3. So why don't we try that? If I remove out 3, this is going to become x squared minus 5x, and then plus 10. And then all divided by, this is going to be 10x plus 3. Now, is there something that can easily factor to make multiplies to make 10, adds to make -5? I would almost argue no, because the factors of 10 are 2 and 5, 1 and 10. There's nothing that will add to make 5 in there. So for this situation, we're probably ending up with a situation where it won't reduce any more than this. The most we can do is just create this common factor of 3 out in front, leave it like this, and we consider this good because that's its fully factored form here. Awesome. And as long as we've stated our NPV, which we did at the beginning, we're happy. Okay, let's do F to wrap up this lesson here. So with this one, right away, I mean, you can't state the NPVs until you factor it. So we need to do our step number 1, and we need to factor this. What we'll do is off to the side, we'll actually do the factors for this one, and then we can rewrite it and continue our problem here. So I'm going to write this as, and actually because it's by inspection, why don't we just do it right below here? This is going to be 3 plus, in the numerator, 5x squared plus 8. Nothing I can factor there because it's a even and an odd, and there's no x's shared on both. Divided by, in the denominator, this is by inspection. If I need to multiply to make -8, but add to make -2, The two numbers that do that for me are x minus 4 and x plus 2. Perfect. Now that I'm at this situation, let's state our MPVs right in the top, just like we've done before. X cannot equal, well, if it equals positive 4, this is 0, and if it equals negative 2, this is 0. So we look at this and we say, as long as it's not either one of these numbers, we're going to be happy. Now what I'm going to do is my LCD, which I'll state below here, LCD, is going to be this x minus 4, x plus 2. Once I've stated this, let's make sure we multiply both pieces by this. So I'll even put an equals sign here. In the step below here, I'm going to put equals. I'm going to leave a bit of space out in front because we know we're going to have to multiply this. This is going to be 3 plus, in the other one, it's going to be 5x squared plus 8. And there's a reason I'm not leaving space in front of this one. It's because it already is the x minus 4, x plus 2. So we're not worried about putting an LCD for that one. Now what I'm going to do is I'm going to write out in front here, x minus 4, x plus 2, and then divided by the x minus 4, x plus 2, because we're multiplying this first term all to that 3. This is going to end up giving us the following. This is 3 x minus 4, x plus 2, plus the 5x squared plus 8, and then all divided by that LCD, which is our x minus 4 and x plus 2. So if we're at this stage of the expansion, what we can do is we can then go equals, and I'm going to expand these binomials all together. So what I'm going to do is expand the 3 into them while also expanding these two binomials. So this piece here, I'm using a bit of mental math. I'm going to go x times x, which is x squared. I multiply it by 3 out front, which gives me 3x squared. I'm going to then take the x times 2 and x times negative 4. That's going to give me a difference of negative 2x. Negative 2x times 3 gives me negative 6x. And then I'm going to go negative 4 times 2 is negative 8, times 3 is going to give me this as our negative 24. Let's just make sure though, if I take negative 4 times negative, or negative 4 times 2 is negative 8, times 3, yes, this does give us negative 24. And then this is going to be plus 5x squared plus 8, all divided by, in the denominator, the common denominator of x minus 4, and then x plus 2. There we go. To wrap this up, we're just going to make sure that we have it in its final collapsed form, or where we combine our like terms. The x squareds come together to make 8x squared. The x's are just negative 6x, so I'm going to leave it as that. I'm just going to make sure that 2 is a little bit better. There we go. And then in terms of 24 plus 8, or negative 24 plus 8, this gives me negative 16. And then this is all divided by the common term of x minus 4 and x plus 2. Awesome. Okay, perfect. Now, what I'm going to do here is I'm just going to move that over just a tad because I realize that it is kind of off-centered a little bit. So this is x minus 4 and then x plus 2. And then me kind of just thinking ahead here, I'm like, okay, well, what can I remove as a common factor here? The only thing I can do is remove out a numerator term of, in this situation, 8, 6, and 16 all divide by 2. So I'm going to divide it by 2 and make this into 4x squared minus 3x. And then 16 divided by 2 is negative 8. There we go. I'm going to close that bracket and then divide it all by, in this situation, x minus 4 and x plus 2. Now, the other thing you could do is you could, on that numerator term, you could be like, what multiplies to make 4 times negative 8, which is negative 32, but then adds to make 3. I don't think we could come up with necessarily a combination that does that, because if we look at it, it's going to be 8 and 4 that are the multiples. We have 2 and 16 that are the multiples. So at this stage, I think that would be more than simplified, and we would be happy with this. As long as we remove that GCF, we're good, and we stated it there. Okay, perfect. Now, in saying with these problems here, part 2 is a lot more similar to these last two problems than it is to the ones above. Now, the reason I say that is because when you get these binomial denominators like this that we need to account for as the LCD, it changes things up a little bit. So that's a little bit of a forward into lesson 6.3 part 2. For 6.3 part 1, our primary focus was, if we have monomial denominators like this, how do we create an LCD? These ones just amplified the difficulty just a little bit, but we're going to focus on a lot of these in 6.3 part 2. Okay, in the meantime, go to the textbook, try some of these practice problems out, ask me questions on them, and then in lesson 6.3 part 2, we'll focus more on these binomial denominators like I said. All right, good luck with your practice.